In this lecture, we are going to calculate the natural frequency and amplitude ratio for forced harmonic vibration and semi-definite system. So we will start with the forced system. Using the equilibrium method, we have to write the equation of motion. A mass m1 is there, so we can write m1 x1 double dot, then it is k1. So here the displacement is 0, and here let us assume that the displacement is x1, and here it is x2, and here it is again 0. So for k1 it is x1 minus 0, then is equal to k into x2 minus x1. So further, a force is acting. Let us consider that the force is acting towards right side direction. So plus f sine omega t. Then the next one, for m2, it is m2 x2 double dot plus k into x2 minus x1 is equal to k2 0 minus x2. Okay, so we'll multiply the k inside and bring the k x2 minus x1 to the left hand side equation. So this is the equation for mass 1 and this is the equation for mass 2. So it is almost like your free vibration system. Only thing here in the free vibration 0 will be there. In the case of forced vibration, f sine omega t will be there. Okay. So we can multiply the k inside. So we will get m1 x1 double dot minus k into x2, then plus k1 plus k x1 is equal to f sine omega t. Similarly for the mass 2, it is m2 x2 double dot plus k plus k2 into x2, then minus k1 is equal to 0. So the solution procedure is same like your previous one. So for simple harmonic motion, x is equal to a sin omega t. So further x dot is omega a cos omega t. So we know that x dot is equal to dx divided by dt. And further x double dot is d square x divided by dt square. So we will get minus omega square a sin omega t. Okay. So we can substitute everything in the equation number 1. So we will get minus m1 a1 omega square. In the place of x1 double dot, I have substituted it as minus omega square a1, then minus x2 in the place of x2 it is a2, then plus k1 plus k in the place of x1 it is a1, that is equal to 0 because we are going to neglect the omega t. So the magnitude of sin omega t or cos omega t is considerably less when compared to the amplitude. So for second mass, it is m2 in the place of x2 double dot, it is minus a2 omega square, then plus k2 instead of x2, it is a2 minus k into instead of x1, it is a1, that is equal to 0. Okay, so now you can bring the a1 and a2 commonly outside. So we will get equation like this. So then we can convert these two equations into matrix form. So this is the matrix. You can bring a1 and a2 outside, that is equal to f into f and 0. So inside the 2 cross 2 matrix you will have k1 plus k minus m1 omega square, then minus k and here it is k plus k2 minus m2 omega square. So further we can write the determinant of this matrix is equal to 0. K1 plus k minus m1 omega square minus k, then k plus k2 m2 omega square, it is equal to 0. So the matrix is same as that of the previous problem. So when you solve this, finally you will get these two values. So omega 1 square is equal to k by m, further omega is equal to root of k by m, and omega 2 square is equal to 3k by m, further omega 2 is equal to root of 3k by m. So okay, so the natural frequency is same like your previous problem because the external forces will never affect the natural frequency of the system. Okay, so that is the conclusion here. Then the amplitude ratio. Okay, so for first equation f will be there, and in the second equation 0 because there is no external force is acting on the mass 2. So when we calculate A1 by A2, then the equation will be Fk divided by K1 plus K minus M1 omega square. Okay. So this is for mode 1, and we know that for mode 1 omega is equal to omega 1, that is equal to root of K by M. Then for mode 2 it is same, A1 by A2 is equal to, use the second equation, it is K plus K2 minus M2 omega square divided by K. And we know that for mode 2 omega is equal to omega 2, that is equal to root of 3K by M. Okay. So this is the amplitude ratio for forced vibration systems. Then the next is semi-definite system. So in a system of 2 degrees of freedom, if one natural frequency is 0, then it is called as semi-definite system. So we will have omega 1 and omega 2. In that, any one of the natural frequency will be equal to 0. So that is why the system is called as semi-definite system. Okay. So we will write the equation of motion first. So it is x1 and x2. There is no external force is acting here. Okay. So for m1, it is m1 x1 double dot, that is equal to k x2 minus x1. Then for m2, it is m2 x2 double dot, then plus k x2 minus x1 is equal to 0. Okay. So you can bring the k x2 minus x1 to the left side. We will get m1 x1 double dot minus k x2 minus x1 is equal to 0. Then the second equation is m2 x2 double dot plus k x2 minus x1 is equal to 0. So now we can multiply the k inside. So we will get m1 x1 double dot minus k into x2 plus k into x1. So minus and minus is plus. Then in the second equation, m2 x2 double dot plus k into x2, then minus k into x1 is equal to 0. So this is equation number 1. And for simple harmonic motion, we know that x is equal to a sin omega t. So x dot is omega a cos omega t, and x double dot is minus omega square a sin omega t. So you can substitute this in the equation number 1. So we will get minus m1 in the place of x1 double dot, it is minus omega square a1. Okay. So in the place of x2, it is minus k a2, then plus k instead of x1, it is a1, that is equal to 0. Similarly for the second equation, x2 double dot is equal to minus omega square a2, then plus k x2, in the place of x2 substitute a2, then minus k into a1, that is equal to 0. So now take the a1 and a2 commonly outside. So we will get k minus m1 omega square into a minus k into a2 is equal to 0. Then here it is minus k into a1 plus k minus m2 omega square into a2 is equal to 0. So the solution procedure is same for all the 2 degrees of freedom systems. So that is why I am going fast. Then you can write this in the matrix form. So it is k minus m1 omega square minus k, then again k minus m2 omega square, and here it is a1, a2, and here it is 0 and 0, it is not f. Then we can write determinant of this matrix is equal to 0. So we can multiply the 2, that is k minus m1 omega square into k minus m2 omega square and minus k square. So minus and minus is plus, that is equal to 0. So if you solve this equation, finally you will get m1 m2 omega power 4, then minus k m1 plus m2 omega square. Okay. So now you can commonly take omega square outside. So here you have omega power 4 and omega square. You can bring the omega square commonly outside. So omega square is equal to 0. So this is your first natural frequency. Further, if you take the omega square outside, then you will get m1 m2 omega square minus k m1 plus m2, that is equal to 0. Okay. So bring the k m1 m2 to the right hand side. So you will get omega square is equal to k m1 plus m2 divided by m1 and m2. Further, omega is equal to root of k m1 plus m2 divided by m1 m2. Okay. So the solution is same for free vibration, forced vibration, and for semi-definite system. So only thing, we have to carefully write the equation of motion. So once if you write the equation of motion clearly, then the solution procedure will be very easy. The tutorial problem: calculate the natural frequencies of the system shown in figure. Take M1 is equal to 10 kg, M2 is equal to 15 kg, and K is equal to 320 Newton per meter. So this is a semi-definite system. Okay. So in this, one of the natural frequencies will be 0. Okay. So you have to follow the same procedure like your previous problem. So yeah, write the equation of motion, then substitute for a simple harmonic motion, then calculate the natural frequency. So use the same procedure up to this. So only after calculation of omega, then you can substitute the value. So you just calculate up to omega is equal to root of k into m1 plus m2 divided by m1 m2. So further in this equation, you can substitute the value of k, m1 and m2. Okay, so that you can verify your solution. So that is how you have to approach the problems on semi-definite system. And the answer is omega 1 is 0 and omega 2 is 7.3 radian per second.